Okay,
Yeah.
thank you. So can everyone hear me? Yes, right?
Yes.
Okay.
Yep.
So this is kind of an obvious thing I have been doing every time I come on a Zoom session. Can everybody hear me? So just come as a habit. So without further ado, let me start today's presentation. And like it's been my pleasure to be a part of this research seminar. My name is Soumyabrata Dev, and I'm a researcher in Adapt Center based in UC Dublin. So today we are going to talk about, as you can see in the title, like how computer vision help us in understanding and identifying product placement locations. So this work is actually a joint work with my colleagues from Adapt Center and Huawei Island Research Center. And we were working on one of their projects. And this particular talk, which I will be talking about today, is actually one of an explorative work that we worked with Huawei, and we wanted to explore further how computer vision can help us. So we are going to talk about this particular aspect of the problem in more detail. So first, the presentation is fairly straightforward. So I will first talk about the background challenge, what exactly is the problem, what we are trying to solve. Then we are going to propose our solution, which is a deep network, how we are going to use that in order to identify product placement. And then we will, of course, validate it using some experiments and some numerical results that we will show. And finally, we will conclude the presentation, give some final thoughts, and what are the future aspects of this presentation. So the background is the whole idea. We are aware that human beings, we have an insatiable appetite for media, and we are consuming media in different forms for since times immemorial. So as you can see here, in a previous time, there was we were consuming a lot of print media. So everybody was we had this appetite, but there were no smartphones and everything. We were mainly focused on print media. But after that, things change. And now fast forward to today's world, there has been a massive growth in technology. And now there are billions of people who have smartphones, and they are accessing more content on demand. Now, there has been a study that people have been spending a huge amount of time on mobiles. And as you can see, this is one of the pictures taken in Singapore, that they have been media, social media or video content on demand, and also on their user phone, on their smartphone. Now this creates a problem for the advertisement agencies or the marketing agencies, that how can we help and get some advertisement or some targeted advertisement to the users, because they are using so much video content on the demand. And is it possible to intelligently give some kind of advertisement to them? So usually how advertisement works in video content is that, for example, you are watching a video, and there is a pause, an advertisement comes in. Sometimes we just skip the advertisement and then proceed with our movie or series, whatever we are seeing. So that, of course, creates problem for the advertisements, because we need to know how can we actually use the content itself and give some personalized content to the user. So that's why the whole idea of product placement comes in. So let me explain what I mean by product placement. So for example, the picture over here shows a screenshot of a video. So this is the left hand side of the picture is an image that we see from a particular video. Now we observe that there is a street with with absolutely nothing. So can we actually add one more advertisement to it? So we added a new advertisement which is artificially added to it. So this advertisement, so once the person sees the video, they will see an advertisement of a car by it, and this is how we are trying to do the product placement. Now this advertisement can be added directly on, as a floating point, or as it can be attached to some particular over the wall, against the wall. So this idea is called a product placement. And the whole talk today, what we are going to do is that, can we identify such candidate spaces? Like, where should I add the advertisement? So those advertisement needs to be added in such a way that it follows the perspective of the user. It should be it shouldn't be a very small advertisement somewhere over here that nobody sees it. It should be in a much more obvious space where people can see it and properly identify that advertisement. So this whole project, this particular talk, we are going to see how computer vision can help us in identifying such product such spaces for product placement. So let me now go to the solution that we have actually devised. So as a part of our work, what we have done is that for parsing such video frames in any video, we use a particular deep network. So our deep network is inspired from FCN network, or the fully convolutional neural network. And as you can see here, this deep network is fairly simple. It's in the form of an encoder and decoder architecture. And of course, I'm not going to go into detail about how many channels and convolution layers are. But as you can see, this is a kind of a very small minimalistic version of a large scale encoder decoder architecture that we are already aware of. Now we call this architecture as DPADS, and the whole idea about this work is that if we have a simple architecture and we can train our model properly for any particular video sequence, it can give us good results, or in some cases better results as compared to state-of-the-art network. So how this network does is that this particular this deep network uses one of this input image as its input, and the final output of the deep network is the 4 points that we have for this product placement. So the idea of this deep network is that can we regress, or can we identify the 4 possible points for deep network. So in order to have that particular deep network, we need, as you know, we need to have a data set where we can train our model and we can identify whether our deep network is going to work well. So in reality, there are in the literature, there are no particular data set that talks about an image and an identifiable place where we can add an advertisement. So as a researcher, what we have done is that we have taken a regular data set called Cityscape dataset. I think most of you are familiar of that. This is a data set consisting of outdoor scenes. So what we have done is that we have collected 10,000 images randomly from Cityscape dataset, and we asked our volunteers, can you place mark a billboard? So for example, what we have this image, and we asked volunteers, can you please mark the location where you can assume that a billboard could be placed? Now, of course, this original image doesn't have any billboard, but our volunteer manually marked these 4 points, saying that, okay, this area marked in pink color might be a good perspective. So the only assumption that we gave to them is that you can make it either floating candidate, or it can be anchored to a particular wall or space. Doesn't really matter, but only restriction that we are giving is that you need to identify only one billboard. Imagine where a new billboard can be. So what is the best possible thing that you can have? Just mark it, don't think too much, just mark and move on to the next image. The reason that why we said, assume, if we think about this particular scene, we can assume the billboard to be placed at anywhere the user has marked over here. We can also think that the billboard can be placed somewhere near the road. So it has different solutions, and we want to have this variability and ask the users, you think what is the best possible approach, and go ahead and mark once, so that we don't need to have any particular solution, but a generalized thing depending upon what best is observed by the volunteer. So we do this humongous task of annotating 10,000 images, and we call this dataset as the CASE dataset. Now, the CASE dataset, we named it as candidate spaces for advert implantation. So that itself indicates that this will help us to understand how we can add new advertisements in it. So this is a sample of few of the images that we have collected from our CASE dataset that we have annotated. For example, we have this particular input image. The user has marked 4 points, which we show here in this binary mask. So by this, we collected billboards of different shapes, different sizes throughout this particular data set. Now, just to give an idea about the variability for this data set that we have manually produced, let's go to here. We show here the percentage of the occurrence. So on the x-axis, we say that how much percentage of the image is covered by the billboard, and y-axis is just the occurrence. So as you can see that, we have a fairly wide distribution of it. Most of the billboards are, covers around 5 or less than 5% of the entire image area, and some billboards are quite large in shape. So this is the distribution of the different sizes of billboard that we have in this CASE dataset that we have proposed. So now once we have the deep network and we have the data set that we have already generated, now let us use it on our data set and see how the results look like. So let us first look into the subjective evaluation and see how our deep ads perform as compared to the other networks. Now on this slide, we can see the input image of one of the 3 input images we are giving example. And we show the results of our thing using a probabilistic map. Now, how to read this probabilistic map is that, for example, if I just consider deep ads, it says that, okay, there is a particular candidate location over here. For this particular image, there is a candidate location somewhere around this. So it doesn't give a particular location, but gives a kind of a probabilistic map or kind of a blob area where we can say that there can be possible location for advertisement. So similarly, we do it for other segmentation based network like FCN, UNet, ENet, and PSPNet, and these are the results that we get.
Sorry, this is supervised learning based on the annotation?
Absolutely.
Okay.
So we use the input image as our input image, and the binary mask that we discussed earlier here as the final input, as the output image. So the idea of this network is that, can I predict this particular binary mask? Of course, it's not possible to do it because there is no perfect solution to it. It's not a segmentation based problem, although we are assuming it as a segmentation based problem, but it's not because there can be multiple solutions to it. And that's why we can see how the heat map is being almost at all over the places. Now, some of the deep network, for example, FCN says that you can absolutely put the billboard anywhere. So that doesn't really solve the problem. And some of them, has a much more PSPNet says, okay, we have to put the billboard somewhere over here. Now, this is everybody will give their own particular assumption where they can have any particular billboard. So how the next step that we can do is that once we have that blob, can we just choose the largest blob of that we have detected and create a bounding box from it and say that whether that particular place is a good location for it. Now, if you observe here that deep ads could actually identify the images, for example, over near the road. For example, here in this case, it has identified on top of it. So it seems to be quite a viable option as compared to the other networks. Now, as researcher, we sometimes we see both from the subjective evaluation, and we also go for objective evaluation and see in terms of the number, how does our network perform as compared to other existing algorithms. So so for this, as I was discussing right now, that we model this entire problem as a segmentation problem. So here we need to classify each pixels in an image, either it belongs to a billboard, if like imaginary billboard, or it doesn't belong to a billboard. So so we can actually try to have the different metrics in order to have this particular method. So we compute the pixel accuracy and the mean accuracy. That means how accurately I can classify each particular pixel in an image to fall to a imaginary billboard class or the background class. Also, as most of you are aware of, that in such kind of detection problems, we also calculate the IOU, or the intersection over union. So which basically means that if I have a actual bounding box and I have a detected bounding box, how these two bounding boxes are related to each other. Are they overlapping well? If they're overlapping well, then it's good. Otherwise, if it's not overlapping well, then IOU will be less. So we compute these four metrics, and we do it for all the different networks. And as you can see that, DPads, like as researcher, I would say that DPads perform the best as compared to all the networks. But as you can see that it fairly works out well, because it, in terms of both accuracy and IOU, it seems to be quite okay as compared to the other deep networks. And and as we have to understand that this is quite a hard problem, because there is no absolute unique solution to it. It can the binary mask can be absolutely anywhere. But as compared to other networks, for example FCN or PSPNet, or even ENet, DPads perform fairly well across all the four metrics that we have done. The other way that we can see this objective evaluation is to have the ROC curve. So ROC curve gives us an understanding about, from the probabilistic map to the binary map, if we use different threshold, how does the deep edge perform? Now, the ROC curve is basically a plot between the true positive rate and the false positive rate across that binary classification. And the main idea here is that any particular method which has the largest area under this curve will be considered as the best. So this is called generally called the AUC, or the area under curve. Now, as you can see, this blue line, which is our DPads, kind of overlaps almost all the other methods, and that means the area under this blue curve is the maximum. And we say, and this is also another way to say that DPads has the better performance for different discrimination thresholds as compared to other network. Now, that kind of gives us an understanding that how DPads, if a network, if it's a small network and if it's trained properly, can actually perform well as compared to the other state-of-the-art method. Now, after that, what we have said is that once we selected a particular imaginary billboard location, can I give a score to the advertisement agencies, or can I give a score to the video editors and say that this particular billboard which you have imagined there, how good that particular billboard is? So for that, we kind of give a placement selection score. And just not to go into very detail, we consider two particular criteria to say whether a particular imaginary billboard or a detected billboard is good. One of them is how well we have identified the billboard using a heat map. And the second thing, which is more interesting for me, is that does this detected billboard really grab the attention of the viewer, or does it fall into the salient region for the human subjective quality? I will talk about this visual saliency in a couple of slides to understand what I mean by it, but let me go into the way how we calculate this score. So this particular placement selection score, that means which gives us an idea that how well that particular billboard is if it is incorporated in a product placement algorithm, a product placement video. So that final score is actually kind of a weighted average of the localization score and this salient score. Localization score is actually the score that means how well we are trying to, if our blob, that as I was showing earlier, if the blob is absolutely all over the place, then the localization score is bad. But if the blob is concentrated on a single area, we will have a good localization score. The saliency score will say that whether that particular area where we have detected the billboard, does it fall into the visual saliency of the viewer. Now, let me go to the next slide quickly to explain what exactly I meant by saliency score or visual saliency of viewers. So salient region or salience is generally quite a regular thing in computer vision. And basically what it indicates is that these are those particular regions of an image that are visually more appealing to or more conspicuous by virtue of their contrast or of their surroundings. They have nice edges, and people will have more attention to that particular area of it. So for example, if I consider any particular image, for example, maybe I take this particular example. So if I look into this image, my eye tracking, or I will be more, my attention will be more towards this bird as compared to the background. So this kind of gives us a kind of a heat map that where the user will have more of visual attention as compared to the other parts. Now, our idea here is that we need to have the billboard in such location that it falls on the visual saliency region of that image. So if it is somewhere in a very obscure location, the viewer might not even see it. But if it's somewhere in a nice location, we will be able to identify the billboard, and that's exactly the solution that we are trying to do. So in the next couple of slides, I'm going to give a few examples to understand what exactly I mean by localization and saliency score, and how this can help the advertisement agencies to give a good understanding of our network. So for example, we have this particular input image, and for example, we have say that this is where the billboard has to be detected. Now, this is an example of a very good localization and poor salient region. Now, using our DPatch network, we could actually identify this billboard quite well. So you can see this is a very nice, clean, localization that we had. So conversion from heat map to a threshold image is fairly nice. But for this particular image, the localized billboard is over here, but the visual saliency is somewhere over here. That means human beings are more likely to see in this side of it rather than on the sides. That means this particular billboard, if we replace this billboard with a new one, of course, we will have a good localization because we could localize it very well, but our saliency score is less. So we have a kind of a weighted average of 0.72, which gives as an indication that this is around 0.72 score if you replace this particular billboard, which is kind of an average of both how good algorithm is and how salient how salient the billboard is. The next example is that we give an example of good localization and good saliency. That means we have identified the billboard quite well, so it's quite nice, clean thing. I'm sorry about that. So it gives a nice threshold image of it. At the same time, the saliency that we have computed using our method, the human visual viewer also lies somewhere over here. So that means it has got a good salience score and good localization, and it gives us a nice score. That means that if you replace this billboard with a new billboard, the advertisement agencies will be in a much more better scenario, because human beings or the viewers will definitely see this particular billboard. So that's roughly what I wanted to say. I think this is quite a. I'm not sure if I have been able to give an understanding of the entire problem that we are having, but this was a quite an interesting work that we are still working on, and to identify not just for a new advert replacement, but also to identify the best location where we can add a new advertisement in a video frame. We believe that again that there's a huge potential of computer vision and machine learning for such sector, because usually in the current domain, generally the video editors, they manually edit the video and manually say that this is where the image there can be a new advertisement. Now if we use such kind of network and we implement it in a video editing software, of course there is still a bit of manual work to understand where to identify the billboard, but we can parse the different frames of a video very quickly, and we can kind of give an understanding of where the billboard can be located, and of course we can do the fine tuning accordingly. This work was done mainly under the assumption that we are just working on 2D advertisement and identify where can I place a new 2D advertisement. So we are currently trying to investigate that can we relax this assumption of 2D advertisement and see if we can use 3D objects seamlessly into the same. So with this, I would like to end this presentation. Thank you so much.